Hello friends, in today's class we are going to talk about least recently used algorithm. So welcome here, and we are talking about least recently used algorithm, and rather than looking into the future, we can't look into the future. We can look into the past, use past knowledge rather than the future. Okay, and it replaces the page that does not used in most recent time. Okay, so replace the page not used in recent time. That is the idea. Okay, so least recently used is replace the pages that is not used in the recent time. Associate time of the last use with each page, and that is one of the implementation that is called as counter implementation. Okay, counter implementation. Okay. So let's implement this. This is the reference string, the same reference string which was 15 page fault generated and optimal was 9. And here we are using recently used. So 7 is the page fault. So let me write here 1 and let me put a dark color in this. Let me put a 1 page fault. Then we have a second page fault. Then we have a third page fault. Now 2 comes, who is not, which one is recently used? So that is 1, 0. So least 7 is what your least recently used, least recently used. Okay, so now 2 will going to replace 7. 2, 0 is a hit. Okay, so 2 was what, your fourth page fault. 0 is what, 0 is a hit. Okay, now 3, okay, the next is your 3, and 3 is not present. So 3 is going to replace one of it. So 0 and 2 are most recently used. So 1 is least recently used, is going to replace 3. And now we have how many? 1, 2, 3, 4. This is 5 page fault. Okay, because I'm designing the bars, this pages only when there is a so that indicate the number of page fault. Okay, so 0 is hit and 4 is a miss. So 0 and 3 is most recently used, and for 4 we are going to replace 2, 4, and that is your sixth page fault. 2 is the 0 and 4 are most recently. 3 will be gone when I'm going to reference this 2, and that means 2, 3 will be gone. 3 is coming, then 2 and 4 are most recently. So 0 will be gone in this case, and this is your 1, 2, 3, 4, 5, 6, 7th page fault. 0 is 3 and 2 are most recently. 4 will be gone, and that will become your 8th page fault. 3 is a hit, 2 is a hit, so 3 is a hit, 2 is a hit, 1 is, and 3 and 2 are recently used, so 0 will be gone. Okay, and that will become your 8, 9, and this is your 10th page fault. Okay, so this is your 10th page fault. 2 is a hit, 0 is not a hit, and 2 and 1 are recently. 3 will be gone, and that will be your 11th page fault. Okay, 11th page fault. 1 is a hit, and 7 is coming to 0 and 1 recently used. 2 will be gone, that will be your 12th page fault. And then we have a hit for 0, and then we have a hit for 1. Okay, so total number of page fault in this case is 12. Okay, so now this is the idea that 7 is a page fault, 0 is a page fault, 1 is a page fault. Okay, and when we are going to have 2, then 7 will be gone, and that is your fourth page fault. 0 is a hit, 3 is a miss, and who is going to replace 0, 2 most recently, 1 will be gone. 0 is a hit, when 4 will come, 0 and 3 most recently, 2 will be gone. When 2 is there, then 4 and 0 most recently, and 3 will be gone. And when 3 comes, 2 and 4, then 0 will be gone. 7th page fault. Basically, I think this is 6, this is 7. Okay, and The next one is your 8. This one is 8 page fault. Okay. Okay, so all gone, all wrong. This will become your 9 page fault. 9 page fault. Okay, and 0 is coming, and so that 3 and 2 are reference, 4 will be gone. Hit 1 is coming, 1 3 and 2, 0 will be gone, and that will be 10th page fault. And 2 is coming, is a hit. 0 is a hit. 0 is not a hit, so 2 and 1 is 3 will be gone. Hit, and 7 is then we got 2 as a hit, right? So that is your least recently used algorithm, and 12 page faults are generated, better than FIFO but worse than your optimal algorithm. Generally it's a good algorithm and frequently used, but the question is how to implement it. So in the next section we are going to talk about LRU implementation. Okay, and that is having a stack base. There is two ways we can implement it. One is counter algorithm, counter based algorithm, and second one is your stack based algorithm. Okay, so I hope you agree with this. That's all for this discussion. Thank you.